Statistics in part B. I will solve the question from 2013 because in class we got different answers, and this will be also a good way to show you how to use the calculator for the statistics questions. First of all, let me remind you again that you have to start from File, New, Document, add calculator, for example, and then read the question. The table below shows the graph of something, number of years, population. So you have to add list, Control, new page, add list and spreadsheet. Here you need to write the name. Do not put X or Y because the calculator will make mistake. Put just words. For example, years, number of years. Here it's population, and then put the numbers 0, 5, 10, 15. For the population we have 71.5, 74.4, 77, 78.8. Draw a scatter diagram for the above table, then Control, new page. We have to draw data statistics. Here is the data, but we have to click to add X variable. X variable will be years, of course, and the Y variable population. This is the scatter diagram. You just have to copy this in your papers. Determine the coordinates of the mean point G of this scatter. You can do this by hand. It's 0 plus 5, it's 15, 15, it's 30 divided by 4, so it's 30. It's 30. Why it's not writing? Okay, 30. 10. Okay, it's the x coordinate of this point. It's when you add these 0, 5, 10, it's 30 divided by 4, which is 7.5 is the x coordinate, and we have to add this 4. And divide by 4. This will be the y coordinate of this point. Then establish an equation of the regression line y on x. So be careful, y on x. This means that like a normal, y is y, x is x. So menu, statistics, stat calculations, linear regression line, equation of the regression line. X list is x, which was years, y list is population, y on x. Y on x, y is here, x is here, y on x. So this is dependent in independent variables. When I click OK, I have the M and B. So this means that the equation is y equals 0.49x plus 71.75. This is y equals mx plus b, and is the coefficient b is the other. The table below gives the growth of the German population over a longer period, starting at 1990. It shows the population, so 0, 5, 10 and 15, but then the data is increased, so I have to add more data here. For years, for example, 35, I have 35, I have 81. for 40. I have 82.1. Yes, the calculator says that there is something wrong because already we have formula here that we calculated, but now I have to change 82.5. Then when it's 50, it's 82.2. Let me check again. 81, 82.1, 82.5, 82.2. And then I have to do the same calculation because no, I have to complete the earlier scatter diagram. When I click here, years, population, I just have to refresh. So I have the scatter diagram. See, this is the new scatter diagram. Again, copy. And then is the linear model of C, is this a linear model? Of course, it's not a linear model. Logarithmic model is more appropriate. That's why we enter a new variable. We say new, for example, new variable. On the second row, you can write the formula directly, by the way, or you can do this by hand, one by one, for each of those. But it's just when I click equal sign, when I'm here and I click equal sign, I can say, okay, new is equal to e to the power of 0.01 times y, which is the population. See, here I have the formula. When I click enter, I have all the values here calculated automatically. Determine the equation of the regression line z on x. If you remember, here was y on x, here it's z on x, so I just have to remember it's D here, menu, statistics, stat calculations, regression line. I will start from D. I will use years for x, and z is the new variable, and that's it. First result column, I can say start from D just to replace the last one. And I must, the operation may override data. Yes, override this. And I have the new results. The regression line. The regression line is y equals 0.004262 x plus 2.09157. Determine the linear correlation coefficient between x and z. It's also here 0.r. It's 0.94469. This correlation coefficient, we have two variables, x and z, so we also can calculate this using menu statistics dot calculations, two variable statistics, which is x is years, and while is it new, and then I have the new also calculations between two variables. You can find r here as well, it's the same, see. So here, if you remember, when we have two variables, we can find also the mean, we can find all the data we need, Q1, Q3, but here we are just asked to find the correlation coefficient, R. If you remember, the core R is 0.94, it's very close to 1, so this means that there is very strong correlation between these two variables. So this means that if the number of years increases, then the population is also increasing. With the help of model E, give an estimate of the population of Germany in 2013. In 2013 it will be okay, starting at 1990, number of years it's 35. So 2013, this will be 1995, 2000, 2005. So 60 will be 2015. So 58, if I'm not wrong, when x is equal to 58. I think this is it. 90 plus 2015, it's 15, 25, 60, yes, 58, I think. Yeah, 58. When x is 58, I can calculate y equals 0.004262 times 58 plus 2.09157, and I will get the result. What else? Do we have any other questions? That there are something else, for example, statistics. Linear model and exponential model in 2016, when we add the data, we can use different models. Add linear regression line and exponential regression curve to your diagram. Okay, let's do this question as well. New document, file new document, and then add list. Here are months, here are Ebola cases, and then you have 0, 1, 2, 3, 4. Here are 242, 419, 759, 1603, 3707. And then draw a scatter plot. Again, control new page, data statistics. Here are the months, here are the Ebola cases. This is the scatter plot. See, this is exponential model. Add linear regression line. You can calculate the regression line. Menu, statistics, stat calculations, linear regression. It's always line. Months, Ebola, and you have the regression line. This is it. But in order to find the exponential line, menu, statistics, stat calculation, menu, statistics, stat calculations, exponential regression, exponential regression. Something happened here with the calculator. Menu, statistics, stat, exponential regression, months, Ebola. Yeah, here is the model, 219, B is 1.797, and determine the linear coefficient for C, D, and E. Use the models because C, it's very close to the real model. And then there is nothing, something. Using the exponential, determine when the people will reach. You just have to solve this equation. We'll reach 50,000 people using the exponential model. So you have to use solve function again for solving. So control, new page, calculator, use the solve function, put this in the calculator. 2019 times 1.97 to the power of x equals 50,000, comma x. 8 million. But I think that's enough.